Now let us see the topic first derivative test. First derivative test, the purpose of this test is to determine maximum or minimum of a given function. Okay, there are 4 cases here. First case, plus minus. Second case, minus plus. Third case, plus plus. And the last case, minus minus. Okay, this test can be divided into 4 categories. Let us see the first category, plus minus. It means, suppose this is the number line and there is a point x0, there is a number x0 on the number line, and in the left hand side of this number line, left hand side of x0, the first derivative value, suppose it is positive, and on the right hand side, the first derivative value is negative. Okay, on the left hand side of x0 function, first derivative value is positive, and on the right hand side of x0, first derivative value is negative. Then this test is saying that at x0 the function is having maximum. So according to this test, function has maximum at x0. Okay, next let us consider the other case, minus comma plus. Suppose this is the number line and this is the point x0, and left hand side of x0, the second derivative value, the first derivative value is negative, and right hand side of x0, the first derivative value is positive. Okay, left hand side first derivative value is negative, and right hand side first derivative value is positive. So according to this test, the function has minimum at the value x0. Okay, now consider the other case. This is the number line and x0, and on the left hand side the function f dash x is positive. Also on the right hand side f dash x is positive. So according to this test, the function has neither maximum nor minimum at x0. So there is no maximum or minimum at x0. And the last case, minus minus, number line, it is x0, and on the left hand side first derivative value is negative, and on the right hand side first derivative value is negative. So by using this test, function has no maximum, no minimum at x0. Okay, so in the case plus comma minus, the function has maximum at x0. In the case minus comma plus, function has minimum at x0. In the case plus comma plus, function has neither maximum nor minimum. And in the case minus minus, function has neither maximum nor minimum. Okay, so you can see that f dash x is positive, means function is increasing function. F dash x is negative, means function is decreasing in this interval and increasing in this interval. So you can observe that x0 will be maximum point for the given function. Okay, if f dash of x is positive, then the function is increasing function. If f dash x is negative, then the function is decreasing function. Correspondingly, x0 will be maximum or minimum for the given function. Now let us consider another example, f of x equals to x power 4. For this function, you need to show that the second derivative test fails to find maximum or minimum, and the first derivative test satisfies the conditions and it is able to find maximum or minimum for the function x power 4. So consider the function x power 4. you need to show that second derivative test fail to find maximum and minimum, and first derivative test is satisfied. First derivative test is useful to find maximum or minimum. So you need to show first derivative test will be useful to find maximum or minimum, and second derivative test fails here. Okay, the function is x power 4. Now let us start derivative. It is 4x cube. Now equate it to 0. It implies x equals to 0. Then 0 is the critical value. It is the critical value. Now find second derivative. It is 12x square, and at 0 second derivative value is also 0. According to second derivative test, if the second derivative value evaluated at some x value, if it is positive, then function has minimum. If it is negative, then function has maximum. Since if second derivative value is 0, so you cannot say whether the function has maximum or minimum. That is, test fails here to determine maxima or minimum of given function. So if this value is positive, you can say function has minimum. If this value is negative, you can say function has maximum. But here the function value is 0, the second derivative value is 0, so you cannot say about maximum and minimum, so the test fails here. Now let us start with the first derivative test. Okay. Okay. Now, according to the previous step, x equals to 0 is the critical value. Okay. So critical value means at this value the maximum or minimum may or may not exist, but second derivative test fails to explain about maximum and minimum. So let us see the first derivative test. So there is a chance of maxima or minima at x equals to 0, since 0 is the critical value. So according to first derivative test, you need to find first derivative value on the left hand side as well as right hand side. In order to apply first derivative test, you need to find f dash x value on the left hand side of 0 as well as on the right hand side of 0. On the left hand side of 0, the values are -1, -2, -3 and so on, all negative values. You substitute those values in the first derivative. Okay, this is first derivative. If you substitute -1, it will be negative, that is -4. If you substitute -2, then also it is negative, that is 4 into -2 whole cube, 4 into -8, -32. Since power is odd power, every time we will get a negative value. So for any x value on the left side of 0, you will get f dash x as negative. Okay. Now on the right hand side of 0 will be 1, 2, 3 and so on. On substituting those values here, you will get positive values. If x equals to 1, 4 into 1, 4, it is a positive value. If it x equals to 2, 4 into 8, 32, it is also positive value. For all right hand side values of 0, you will get f dash x as positive. Okay. So according to first derivative test, you will have minimum at x equals to 0. Okay, so we have applied case minus comma plus, according to that case, the function will have minimum at x equals to 0. Left hand side, first derivative value is negative. Right hand side, first derivative value is positive. So function has minimum at x equals to 0. So in this way, first derivative test is helpful to find maximum or minimum of the given function. And also you need to find minimum value. So minimum value is f of 0. This will be 0 power 4, that is 0. Okay. So the minimum value is 0. Thank you. So find maximum or minimum of f of x by using first derivative test. Okay. Now let us start finding critical value. Find derivative. It is 2x plus 2 equated to 0. The next value is minus 1. So we can say minus 1 is the critical value. Now take the number line. This is minus 1. Okay. Now find f dash x on the left hand side as well as on the right hand side. Okay. Let us start with the right hand side. The right hand side values of minus 1 are 0, 1, 2, 3 and so on. You substitute 0, 1, 2, 3 and so on in first derivative. Okay. If you substitute 0, the answer is 2 and it is positive. If you substitute 1, the answer is 2 plus 2, 4. Again it is positive. If you substitute 3, it is 6 plus 2, 8, it is also positive. For all the values on the right hand side of minus 1, the first derivative is positive. Now let us take some x values on the left hand side. Okay. One value is minus 2. At minus 2, it will be 2 into minus 2, minus 4 plus 2, it is minus 2. So it is negative. Now take another value, minus 3 on the left hand side of minus 1. If it is minus 3, it is 2 into minus 3, minus 6 plus 2, minus 4. It is also negative. Okay. So on the left hand side of minus 1, the first derivative values are negative. And on the right hand side of minus 1, the first derivative values are positive. So according to minus comma plus test, you can say that the function has minimum at x equals to minus 1. So by using first derivative test, f of x has minimum at x equals to minus 1 and minimum value is f of minus 1. This is equals to minus 1 whole square, 2 into minus 1 minus 3, it is 1 minus 2 minus 3, it is minus 4. So minus 4 is the minimum value by using first derivative test. Function is f of x equals to 2 minus x whole cube, and you need to find maximum or minimum for this function by using first derivative test. Let us start with f dash of x. So this is 3 into 2 minus x whole square and internal derivative is minus 1. Let us equate it to 0. Now we will get x value as 2 and 2 is the critical value. Now apply first derivative test. So this is number line and this is 2. Okay. Now you need to evaluate first derivative value on the right hand side as well as on the left hand side. So this is right hand side. You need to evaluate first derivative value on the right hand side as well as on the left hand side. Let us take a value 3 on the right hand side. Substitute 3 in f dash x. It will be minus 3 into 2 minus 3 whole square. It is a negative quantity. Okay. At 3, you got first derivative value as negative. Now you take 4. At 4, it is 2 minus 4 whole square. It is minus 2 square, that is 4. 4 into 3, 12. 12 into minus 1, minus 12. It is also negative. If you take 5 also, then because of this minus sign, you will get negative value. So for every x value on the right hand side, you are getting first derivative value as negative. Now consider the values on the left hand side of 2. The values are 1, 0, minus 1 and so on. Now at 1, if you write 1, it will be 2 minus 1, 1. 1 into 3, 3. 3 into minus 1, it is minus 3. Okay, so minus 3 is the negative value. Okay, now you take 0. If you take 0, it is 3 into 4, 12. 12 into minus 1, minus 12. Then also first derivative value is negative. If you take minus 1, it will be 2 plus 1, 3. 3 square, 9. 9 into 3, 27. 27 into minus 1, minus 27. Then also the first derivative value is negative. Okay, for every x value on the right hand side, you got first derivative as negative. For every x value on the left hand side, you got first derivative value as negative. So according to minus comma minus test, you will have neither maximum nor minimum at x equals to 2. So f has neither maximum nor minimum at x equals to 2. Now let us take another example. F of x equals to x cube plus 2x square minus 4x minus 8. You need to find maximum or minimum for this function by using first derivative test. Now let us find critical value. F dash x equals to 3x square plus 2 into 2x minus 4 equated to 0. Now it is 3x square plus 4x minus 4 equals to 0. It is 3x square plus 6x minus 2x minus 4 equals to 0. Take 3x common, x plus 2. Take minus 2 common, x plus 2 is 0. Now it is x plus 2 into 3x minus 2. Now it is x equals to minus 2 and 2 by 3. These are critical values. So at these values, the maximum or minimum may or may not exist. Now let us apply first derivative test. So this is number line. Let us consider 2 by 3. Okay. So 2 by 3 is around 0.6. Now take values on the right hand side of 0.6. Let us consider 1. Okay. So you substitute 1 in the first derivative. It will be 3 plus 4, 7, 7 minus 4, 3, it is positive. Okay. For x equals to 1, first derivative value is positive. You take 2. If it is 2, 3 into 4, 12, plus 4 into 2, 8, 12 plus 8, 20, 20 minus 4, 16, then it is positive. If you take 3, then it will be 3 into 9, 27, 4 into 3, 12, that is 39, 39 minus 4, 35, it is also positive. So for the values on the right hand side of 2 by 3, you are getting first derivative as a positive quantity. Now you take some values on the left hand side of 2 by 3. Okay, so 2 by 3 is same as 0.6. The left hand side values will be starts from 0. Okay, let us take a value 0. If we substitute here, it will be minus 4. So for 0, you are getting first derivative value as negative. You take minus 1 on the left hand side of 2 by 3. If it is minus 1, it will be 3 into minus 1, it is 3. 3 minus 4, minus 4. 3 minus 8, it is minus 5. It is negative quantity. Okay. You take minus 2. It is 3 into 4, 12. Okay. And it is 2 into 2 into minus 2. It is minus 8. So 12 minus 12, it is 0. So you are getting 0 here. Okay. So you cannot decide whether it is positive or negative, you take another value, you take minus 3. Then it will be 3 into 9, 27. Then 4 into minus 3, it is 27 minus 12, it is 15. 15 minus 4, 15 minus 4, and it is 11. Okay. So at minus 1, sorry, at minus 2, so you are getting 0. Okay. So till minus 2, you are getting the function value is negative. So you conclude that the function has minimum at x equals to 2 by 3. So according to minus comma plus test, the function has minimum at x equals to 2 by 3, and you need to find minimum value. Okay, and minimum value is f of 2 by 3. It is 2 by 3 whole cube, 2 into 2 by 3 whole square, minus 4 into 2 by 3 minus 8. Okay, so it will be 8 by 27 plus 8 by 9 minus 8 by 3 minus 8. Okay, so this will be the minimum value of the given function. Now let us check whether the function has maximum or minimum at x equals to minus 2. Okay, so on the right hand side of minus 2, you take minus 1. So for minus 1, we have already seen first derivative is 3x square plus 4x minus 4. Okay, if you write minus 1, it will be 3 minus 8 minus 5. So on the right hand side, the first derivative value is negative, and on the left hand side you take minus 3. If you take minus 3, it will be 3 into minus 3 whole square, 3 into 9, 27, 27 minus 12, 15, 15 minus 4, 11. It is positive quantity. And on the left hand side, first derivative value is positive. So according to first derivative test, you can conclude that function has maximum at x equals to minus 2. And maximum value is of minus 2. It is minus 8 plus 8 minus 8. It is minus 16. Minus 16 is the maximum value for the given function. The topic: concave upward or concave downward. Okay, so this is concave upward and this is concave downward. Okay, suppose a function is given and its first derivative is also calculated. Okay, if the derivative of first derivative is positive, then we can say the function is concave upward. Okay, a function is given and we have calculated first derivative. If the derivative of first derivative is positive for every x value, then we can say that the function is concave upward. This is same as f double dash of x is positive. Okay, suppose if the derivative of first derivative is negative, that is f double dash of x is negative, then we can say that then we can say that function is concave downwards. Okay, if the second derivative is positive for every x value, then we can say that function is concave upward. If the second derivative is negative for every x value, then we can say that function is concave downward. Say function is given 3x power 4 minus 16x cube plus 24x square plus 48. You need to show that this function is concave downward. Okay, so let us start first derivative. So it is 12x cube minus 16 into 3x square plus 24 into 2x. Okay, it is 12x cube minus 48x square plus 48x. Now let us take 12x common. Okay, so taking 12x common, it will be okay. Now find second derivative. It is 36x square minus 96x plus 48. Okay, 36x square minus 96x plus 48. Suppose you take some values for x. If x equals to 0, then second derivative value is positive 48 and it is positive. You take x equals to 1, then second derivative value is 36 plus 48 minus 96. It will be 84 minus 96 and it is negative. You take x equals to minus 1. You take x equals to minus 1, then it will be 36 plus 96 plus 48. Okay, it is also positive. Okay, you take another value x equals to minus 2, then f double dash of minus 2 is 36 into 4 plus 96 into 2 plus 48 and it is also positive. Okay, so we can see that if it is number line, for 0 second derivative value is positive, and for minus 1 the quantity is positive, second derivative is positive. For minus 2 second derivative is positive. So you can conclude that the second derivative is positive for every value on the left hand side of 0. So this function is concave upward in the interval minus infinity comma 0. So we can conclude that f is concave upward for the values minus infinity comma 0. Suppose if you have taken 1, 2 and so on, for 1 you got the value as negative. Suppose if you have taken 2, it will be 36 into 4 minus 96 into 2 plus 48. It is also negative value. So you can conclude that the function is concave downward for the values on the right hand side of 0. That is, f is concave downwards on 0 comma infinity. On the left hand side the second derivative will be positive, so function is concave upward on the left hand side of 0, and on the right hand side of 0 the second derivative values are negative. So you can conclude that the function is concave downward on the right hand side of 0, that is on the interval 0 comma infinity.